Okay, so the problem we were given is a heating wire is used to transfer 8.79 kilojoules of energy to a 96.5 gram sample of zinc. The specific heat of the zinc is 0.39 joules per grams degrees Celsius. The final temperature of the zinc was 637 degrees Fahrenheit. What was the initial temperature of the zinc in degrees Fahrenheit? So the first thing we want to do in this problem is convert the kilojoules to joules and the degrees Fahrenheit to degrees Celsius. I know that the problem is asking for degrees Fahrenheit, but because our specific heat is giving us the joules, we have to convert the kilojoules, and it's giving us the Celsius, so you have to convert the degrees Fahrenheit to degrees Celsius. So I'm going to start off by converting the kilojoules to joules. Okay, and to convert the kilojoules to joules, we are going to write out our conversion factor. So we're converting to joules, so we want to make sure that the kilojoules cancel out. So we're going to write down the kilojoules on the bottom and the joules on the very top. So we should know that the prefix kilo stands for 1 times 10 to the third. So 1 kilojoule sorry, I misspelled the joule, is equal to 1,000, right? Joules. So we're going to put the 1 kilojoule on the bottom because it's the larger unit, and then 1,000 on the top, which is going to equal to 8,790 joules. And now we're going to convert our degrees Fahrenheit to degrees Celsius. Okay, so now we're going to convert the degrees Fahrenheit to degrees Celsius. And this is the equation we're going to be using for this. So now we're just going to have to plug in the degrees Fahrenheit into this equation here, which would be 637 minus 32 over 1.8. So if you're going to solve this on a calculator, what you want to do first is put parentheses 637 minus 32, and then parentheses, and then divided by 1.8 to give you your answer for this question. And you would be looking at 336.11 degrees Celsius. But you always want to look at your significant figures that you are given. So for this problem, we have 3 significant figures. You wouldn't use these figures because these are exact numbers. So you're going to use your 3 significant figures, which would be this 336, and you're going to round to 336 degrees Celsius. And now we have found our joules and our degrees Celsius. So now we can start to solve for our problem now. Okay, so now we have written out our heat equation, which is this right here. And this is what we're going to use to find the initial temperature of the zinc in degrees Fahrenheit. So what I like to do when I start off my problems is list all of my factors. So I have the heat, which we converted to joules. I have my mass. I have my specific heat. And we have part of our temperature here. So now we can start plugging in all of our units into our equation. So I'm going to start off with the heat, which is 8,790 joules is equal to our mass, which is 96.5 grams, times our specific heat, which is 0.39 joules per grams degrees Celsius, and then times our temperature, which we are going to have to find our initial temperature, because that's what our problem is asking for, degrees Celsius minus x, because we have no idea what this number here is yet. Okay, and now we can begin to start solving for our problem. So the way we're going to start with this is going to be by multiplying these two numbers right here, which now we're going to come out with the number 37.635 joules and degrees Celsius, because our grams are going to cancel out. So we're only left with the joules and degrees Celsius. And then now we're going to have to bring down our 336 degrees Celsius minus x. And then we keep our joules. Okay. And now we're going to do our basic algebra to find x, right? So we're going to go ahead and divide this by the 37.635 joules per degree Celsius. So 37.635 joules degrees Celsius, and this cancels out, and then we divide it on the other side as well. 37.635 joules and degrees Celsius, and then these two cancel out there, and now we get our answer. Okay, so the answer to our solution here is going to be 233.5591869 degrees Celsius. Crazy number, huh? But that's what our calculator is giving us. So that's where we're going to put in there for now. We don't need our significant figures till the end of our problem. So now we're going to subtract the 336 on both sides. And now we have 102.44083131 degrees Celsius, and that's going to be a negative number, and then that is equal to negative x, and then you divide the negative number out to give you a positive number, which is of, and sorry, my camera had moved right now as I was finishing the problem up. So our solution here is a 102 degrees Celsius, and that is going to be our solution for this. But our problem is actually asking for us to solve for degrees Fahrenheit. So we're going to now convert this degrees Celsius to degrees Fahrenheit. Okay, and our problem was asking for us to solve in degrees Fahrenheit. So now what we have to do is actually convert our degrees Celsius to degrees Fahrenheit. And the way we're going to do that is we're going to take our answer, which was 102 degrees Celsius, 102 degrees Celsius, plus the 32 times 1.8 is going to give us our degrees Fahrenheit. So we're going to go ahead and solve for this, which is equal to 241.2 degrees Fahrenheit. Now we want to remember and go all the way back to the beginning of our problem and actually see how many significant figures we had to begin with. And it looks like the smallest figure that we have here is 2 figures. So what we can do is simplify our numbers to 2 significant figures down here. There we go. Now it's writing. And we would actually get 240 degrees Fahrenheit. And that is going to be our answer for the initial temperature on our question. Thank you.